Okay. Let me try to fix. Is it any better now?
Yes, sir, it's better now.
Okay.
So may I start with your introduction if you allow me?
Yes, please.
I welcome all the participants to the session 2 of day 5 of Faculty Development Program on New Approaches in Geotechnical Earthquake Engineering sponsored by the ATAL Academy. And we have with us Dr. Vipin Kumar sir. He is a project scientist at HNB Garhwal University, Uttarakhand. He has been former senior fellow at University of Liège, Belgium and ETH Zurich. He has also been a former university lecturer in the HNB Garhwal University, Uttarakhand, and he has taught engineering geology during his tenure. He has been working as an engineering geologist in geotechnical consulting firm on projects involving buildings, dam, bridges, highways, refineries, and so on, with specialization in engineering geology, geodesic, and environmental sciences. He is a graduate and postgraduate from University of Delhi. He has been working on the topic of in the landslides in the Northwest Himalayas during his research, doctoral research from Wadia Institute of Himalaya Geology, HNB Garhwal University. During his doctoral research, he was working as a CSIR JRF fellow. And in his doctoral, he was working on developing numerical simulation based approaches for slope stability and debris flow runout simulations. He has published around 12 research articles in Q1 index journals with citations of 199 and H index of 7, and also working as a reviewer of scientific reports, Nature, Natural Hazards, Geomorphology, and many other reputed journals. We welcome you, sir, and we thank you for accepting our request and enlightening us over this faculty development program on geotechnical earthquake engineering. I request sir to please take over the session now.
Thank you so much. And I think it's normal that I cannot see other candidates. Is it?
Yes, sir. So
Okay.
if you share the screen, you won't be able to like see the participants.
Okay. Let me share the screen. And whether my PPT is visible now? I hope so. Is it
Sir, it's
visible?
appearing. It's appearing, sir. Yes, sir. It's we can see
Okay.
that.
Okay.
Sir, I request you to please switch on your camera just for a moment so we
Okay.
can just see you.
Okay. Switch. Actually, my camera is already switched on.
So you're not visible at our end.
Okay. Let me try again something. Just a minute. Just a minute.
Yes, sir. We can see you now.
Okay. Perfect.
We welcome you, sir, to this
Thank
faculty
you.
development program, and we are very much thankful that you accepted our request and could be present here with us today.
Thank you. So let's start now.
Yes, sir.
Thank you. There seemed to be some problem is sharing. Is it visible?
No, sir. Not yet, sir.
Okay, like it's showing only meeting organizers and
No,
presenters
sir.
can share.
Yes, sir. I've made you a presenter, sir.
Hmm.
From my side, it's active. Is it appearing on your screen as well, sir?
Yes, let me try to do something.
Yes, sir. If it's not appearing, then I request you to log out and then come again.
Yes, I think that would be appropriate. Is it audible now? Is it audible now?
So you're audible, but we cannot see the screen, sir.
Yeah, this problem. And like my voice is echoing. I don't know what's the problem. I cannot share my screen. Same message only meeting organizers and presenters can share.
So I'll try once again.
Mhm.
So is it appearing now?
No, I mean it's still the same message that only meeting organizers and presenters can share. Okay, let me try again. Let me try again. I will hang up and then join. I'm really sorry.
No problem, sir.
Is it audible?
Yes, sir, it's audible.
I got it. I think when I'm
Yes, sir.
making my screen in the sharing mode, my camera is not working. I don't know why.
Okay, sir, it's no problem. You can switch off
Mhm,
the camera. Now the screen
mhm.
is visible to us.
Okay, so I'll start.
Yes, sir. Sir, please make
So
it in the full slide, full presentation mode, sir.
actually, it is in full
Sir,
screen
probably that zoom in the bottom is not full. Yes, sir. Now it's visible, sir.
now.
Sir, it was appearing earlier. Yes, sir. Now it's visible. Yes.
Okay. Okay, like my spelling of Uttarakhand is a little bit wrong. Yeah. Okay, so good. Well, it's going to be good afternoon after a few minutes. So today I'll try to share my insights about how we can evaluate the response of hill slopes in case of earthquake and extreme rainfall. As you all might be aware of, that in our country we have two prominent mountain ranges, Himalaya, which generally we describe in the form of Northwest Himalaya, Central Himalaya, and Northeast Himalaya, and Western Ghats. So in this lecture, I have involved two case studies, one in Northwest Himalaya, India, and one Southeast Carpathians, Romania. For information, I would like to tell you that the Carpathian Mountains have similar orogeny like Himalaya. Both were subjected once to the Tethyan Sea, which was, subjected to the continent-continent collision and gave rise to the mountain. So I'm starting. When I say hill slope, we are talking about any general hill slope which might develop into a landslide. As in the top left picture, you can see this picture belongs to November 2013 in the Yamuna Valley. There were few
So sorry
episodic.
to disturb you, sir. The slides are not changing. Yes, sir. Now it's appearing, sir.
Okay. Maybe there's a time lapse.
Yes, sir. Yes.
So in this top left picture, which is of November 2013, you can see that there are like gully, or I would say the rills type of slope failure impressions, whereas in a period of 8 years it has developed into a huge landslide equivalent to size of 9.1 million meter square. And this top right picture is the front view of the same landslide which we mapped using DGPS and total station. For the sake of scale, you can understand that right, this white circle, it represents this house which is of 10 into 10 meter. So you can understand the hugeness of this landslide. It literally blocked the Char Dham Yatra for a period of 7 days, and then the administration made another temporary road at a cost of 20 crores. So landslides are not only threat to the life, but also to the economy. So it is a kind of social and economic disaster if not evaluated in advance. The next slide, I hope it's visible. This slide is of a hill slope in Satluj River Valley, might be aware of in the Himachal Pradesh. So using these four pictures of Google Earth, I'm trying to show that how a hill slope, when there was no prominent impression of landslide, it developed in a period of 12 years into a huge landslide, engulfing apple orchards and many houses of this Urni village in Himachal Pradesh. And at present, the government of Himachal Pradesh is planning to make a tunnel bypassing this road. But I'm not sure about the successful outcome of the tunnel because the hill slope in this region are becoming more and more subjected to hill slope failure activity. So why is it necessary to predict hill slope response? This is not confined to geologists or landslide researchers. It is a matter of concern for everyone. So why do we need to predict? This is a global pattern that every year we are subjected to a loss of more than 4,000 lives. And in the last 2 decades, we have lost 20,000 lives caused by landslides. India and Nepal accounting for 54% of life loss caused by landslides. India only accounts for more than 10,000 lives. And this is a particular case of our country, as I can show you using different dots. This dot, it belongs to Uttarakhand. As you might be aware of that in 2013 we had a flash flood and so many landslides, and recently in Feb 2021 we lost more than 6,000 lives, and this is a very, I would say, the lower cap of the loss. Actual figures might be higher than that. And then in Malin landslide in Maharashtra, then the Kerala flood and landslides, the Nilgiri, and then Arunachal Pradesh and Sikkim. So you can see that all the periphery of our country is subjected to this problem. And if some of you have a mathematical background or physical background, you will understand then when we say the hill slope response, it is in terms of the displacement, failure potential, stress, ground motion, and runout. These are some technical terms which we use to evaluate the response, how much it can displace, what is the probability of failure or the potential of failure, how much stress it is accumulating, the ground motion during earthquake, and the runout during in case of excessive rainfall. So how do we predict? We have two different types of approach, the regional scale approach and the slope scale approach. Sorry for interruption. If any one of you have any doubt at any slide, please interrupt. So the regional scale approach, generally we define with the term of zonation, which could be susceptibility or vulnerability. In this chart, pie chart, I'm trying to show that 60% of studies in India during like last 5 decades, I would say, have been about zonation, and only 5% about the monitoring, and numerical simulation accounts for 15%. So far in our country, majority of the studies have been zonation, which I consider a very traditional approach, a kind of post-disaster scenario. Just to understand, we need to be more specific in order to counter such disastrous process to save the life and economy. So we need to focus on slope scale approaches. There have been generalized approaches like RMR and Q, but I would say these are very preliminary approaches. So nowadays, researchers are investing time and money into numerical simulations to understand the behavior of hill slopes and then monitoring, followed by the numerical simulation. It could be stability simulation, it could be movement simulation. Again, the stability simulation could be continuum, discontinuum, or the combination of both, which we define as hybrid. And the movement simulation could be single phase or multiple phase. If any one of you is interested to know more about these terms, I will define later. I mean, you can ask me in detail later. So this is a case study of Southeast Carpathian in Romania. In this picture, you can see the location of the landslide. This picture represents the location of a study area in Eurasia. This is the Carpathian Mountain. This is the geological setup, and this is the landslide. The size of landslide in terms of area is approximately 9.5 million meters square. As you can see, it is traversed by many, structural factors like faults and folds. On the right side, you will see the position of study area and the earthquake distribution. Each red circle represents one specific earthquake event having a magnitude more than 4 and less than 8. So, and this study area is situated in the Branchia seismic zone, which is one of the most seismically active region in Europe. And this is the climatic pattern in the study area. In this picture, you can see that since 1980 at present, the rainfall has increased, and similarly the soil moisture and the surface runoff, which I would say are associated parameters implicating the climate change, which is a kind of hot topic at present. So all these parameters are increasing in a period of last 30 years. And this is annual scale, which we represented in the form of box plots in order to counter the uncertainty or in order to better understand the uncertainty. This is the monthly distribution. Everything in a nutshell is that rainfall and associated parameters like soil moisture and surface runoff, which contribute in the hill slope failure or in landslide, these parameters are accelerating in a period of last 30 years. And then this is the daily scale. As you can see, the red line, it represents the daily threshold in the region, which is 30 mm in 24 hours. If the rainfall is more than that, it in general results in a localized debris flow. And this plot, it represents those months when all three parameters like rainfall, soil moisture, and surface runoff were at its peak. And these are mostly in 2005 and 2010. I would like to mention that 2005 and 2010, in the same years in Himalaya also, we witnessed increased rainfall and associated parameters like soil moisture and surface runoff. And in our recent study, which is still in the process, we are trying to understand all such climatic pattern in the entire Northwest Himalaya involving 5 major river valleys. So this is the Google Earth image of the landslide in southeast Carpathian Romania. Different perspectives. This is the side view. Then you can see some seasonal gully and channels, the paleo detachment depression, and some localized failure and their zoomed version. This study is not anymore in preparation. It has been accepted actually now. And this is the methodology that we used. We used satellite images to understand the rainfall, geomorphological mapping, digital elevation model, and then we perform field work in the form of HV. HV is horizontal to vertical measurement to measure the ambient noise, and that we used to measure V, and that was coupled with VP and VS measurement and some depth profiles. All these parameters were used to prepare a 3D model, and this 3D model was further used to perform slope stability evaluation using distinct element model and debris flow Renault simulation. For metal property, we perform geotechnical analysis on the samples collected from the field. This picture represents that how we got the 2D cross section from starting. So this picture in the top left, it represents a 3D view of the landslide, and these small circles, the blue and the yellow and the red, represents the peak frequency that we measured from the HP measurement. And along with the digital elevation model that we had, we made a 3D model having a soil thickness, and then we used different cross sections, 2D sections. Now the question is, if we had 3D model, why did we perform 2D slope stability analysis? And the reason is, in order to perform three-dimensional slope stability analysis, we need to have subsurface joint pattern or the discontinuity pattern. We need to have the groundwater behavior in the subsurface, which at present we are not sure of. So that's why we kept our study confined at 2D in terms of slope stability analysis. But maybe in few years, when we will be more confident about the subsurface pattern, we are hopeful to perform the same. And this is the output, of all the slope sections. As I showed you, we took 4 different slope sections. So the CS1, CS2, CS3, and CS4, these are displacement, and these are different conditions. So the displacement of each model under different conditions like static, static plus groundwater, dynamic, dynamic plus groundwater. And the dynamic plus groundwater, you will see the 2 times because the Friuli. In this case, we used Friuli earthquake, the Italy earthquake 1971, and here we used a Ricker wavelet, a theoretical waveform, to evaluate the PGA. So we evaluated the response of different slopes under different conditions, and then the PGA, the P ground acceleration at the surface at all 4 models in order to understand the response under earthquake, and because the area is subjected to earthquake. And this picture represents the potential debris flow runout in case of extreme rainfall. As I showed you initially, that the region is subjected to extreme rainfall, surface runoff, and soil moisture. So we performed debris flow simulation. This picture represents the soil thickness. This picture represents the region which we focused for the debris flow simulation. This picture is used to highlight the river channel along which the debris flow, once coming from the slope, will strike the river flow. And this picture in the bottom left represents the debris flow height and then the debris flow velocity. And once this debris flow coming from the hill slope will strike the river. This will be the pattern along the river channel. And then we overlaid our results on the Google Earth imagery to better understand. And here we found that the debris flow, once it will start, it will block the river and it will actually cross the river and to reach on the opposite side. And then we found that at both these two locations, river attains a huge sinuosity, implying that the same area has been subjected to such debris flow behavior in the past and then forcing the river channel to attain this sinuosity. So the debris flow on hill slope and the river channel, they are in a feedback process. Sometimes debris flow affect the river channel behavior and sometimes river channel affect the debris flow behavior. And the next case studies from the northwest Himalaya, India, in the Himachal Pradesh, Satluj River Valley. You might be aware of these terms like the Rampur in Shimla district, the Nachar, and then Kalpa in Kinnaur district, Akpa and Poo. So we took 56 landslides along the Satluj River Valley. Then we performed, before I come to the slope stability, this is the earthquake distribution in the study area. The majority of the earthquakes are confined within a depth of 40 kilometer, having a magnitude less than 7. And this is the rainfall pattern in this study area. As you can see, the rainfall is increasing in the study area. The green bars represents the events or the year when the area was subjected to the flash floods. Okay, now this is the output which we are interested in. The factor of safety of each landslide, the total displacement, the area, volume, and the human population. Now this is something social perspective which we included in our analysis. So the gray bar, it represents that the landslides having the lowest factor of safety have relatively higher volume and area. And unfortunately, 75% human population in the study area is confined in this region. So you can see that how the natural process are affecting the social process. The landslides having the lowest factor of safety, biggest dimensions, comprising the maximum population. On the right side, this is another, I would say, application that we explored, that what will happen if a landslide blocks a river. Because in Himalaya, I would say in our country, we do not have much understanding about landslide lake or the outburst process if it happens. So in 2019, in this paper, I would say this is the first study that we tried to predict the potential landslide dam if it happens in Satluj Valley. So we used landslide volume and valley width parameters to find that which landslides may contribute in the formation of landslide dam, and if they contribute, whether the landslide dam would be stable or unstable. We found some landslides that might be responsible, but they are in uncertain domain, means they might be stable or unstable. So these are the landslides which will form the landslide dam in case of slope failure. So please don't lose the thread. We started from the hill slope that have potential to be the landslide, and then we perform slope stability and run out simulations. And once a slope is unstable, it will fail, it will block a river, it will form a landslide dam. So this is the application, that is the final application we explored. This right picture represents this landslide, and we found that this area has been subjected to this landslide damming even in the past, which we are making comment based on this sediment sequence. When you have such like a strain sequence, like a fine coarse, this sequence, it represents a lacustrine deposit. So a lacustrine deposit at the bank of a fluvial sequence or the river channel, it represents the formation of lake, which probably formed by the landslide damming. And now there are still some research gaps in our country, in our Himalaya, I would say, the predicting potential landslide damming sites in Himalaya. That is under process. We are doing that. potential lake outburst flood scenario, and submarine landslides and potential consequences, because recently Government of India allowed the deep sea mining, but unfortunately we do not have any account of any submarine landslide. Thank you. Now I would welcome your questions. Hello, is it audible?
Yes, sir. Thank you so much, sir, for this wonderful session.
Thank you.
And I request the participants to please unmute themselves or even type in the chat box. Please have an interaction with Vipin, sir, so that your concepts get cleared in a much better way. Sir, we have a question in the chat box that
Okay, so I'll look at the chat box. Okay. Hello, sir. What was your other source of data collection other than past history and GIS software? Other source of data collection. Okay, now this is a very, I would say, the broad question. This is not specific, but I would say when it comes to the climatic parameters, we used the open source data provided by the NASA. When it comes to earthquake, we used I mean, it was a data provided on the basis of request. In case of Romania, we requested the National Institute of Earth Physics in Romania. In case of Himalaya, we got this data, I mean, from different sources in our country, but they will provide. If it is for research purpose, they provide such kind of data. Whereas the data of landslide, we went to field, we collected the samples, we performed the geotechnical analysis, and we got this data. Is it audible?
yes, sir.
And one more question: can we use Plexus software for the analysis? Yes, the Plexus is also another very common software for finite element analysis, but nowadays distinct element methods are becoming more and more common due to their flexibility in dealing with dynamic analysis.
Okay, okay. Thank you, sir.
Thank you.
Sir, can you give us an elaborate explanation of how you performed this study? हाँ बैठ जाओ. Sir, there is, sir, am I audible, sir? I think probably sir has lost the connection. He will be getting in touch with us soon. So there is some network connectivity issue at sir's end. I request the participants to please be patient with us.
Okay, ma'am.
Sir, you are not audible. Vipin sir?
Am I audible now?
Yes, sir. Even the screen has got stuck at our end.
I don't know, maybe some connectivity issue. But now is it
Yes, sir.
now is it connected?
Yes, sir. Yes, sir. Now you are getting connected.
Okay, so I was saying that the presentation was about predicting hill slope response, and now, if you allow me, I would share some insightful observations from Northwest Himalaya.
Yes, sir. Please, sir. There is one more question in the chat box. That
Okay.
for geostatistical modeling of
Uh-huh.
geotechnical system, a
Uh-huh.
substantial report on soil investigation is needed. Is
Mhm.
it possible to obtain such data? How do we have to apply for it?
Okay, so now this question, let me understand a geostatistical modeling of geotechnical system. We need to be specific. Uh, Shashwata Chatterjee. If what I can understand, geostatistical modeling, it could be in many ways. I mean, it could be about artificial hill slope. It could be a natural hill slope. It could be any man-made or natural structure. Now, for geostatistics modeling of geotechnical systems needed, is it possible? Okay, yes, of course, it is possible to obtain such kind of data. I mean, you can perform field work, you can perform geotechnical analysis as far as external parameters are concerned. For example, the dynamic data called earthquake data or the earthquake source data that you can use to compare the PGA values collected from your modeling results, and you can compare with the actual PGA observed at different stations. And in our country, NGRI, National Geophysical Research Institute, Vadian State of Himalayan Geology, they have their own network to provide such data. So your geotechnical evaluation, which you performed using numerical simulation, it can be compared with the natural observation that we have in the field. So yes, we can have such kind of data. I mean, my response is based on what I comprehended from your question. But if you have some other specific question, you can ask me. I mean, geotechnical system, it's a broad term. Is it audible, Ms. Shashwata Chatterjee?
I hope that question is answered. Yes, sir.
Okay. No, she's saying, I mean that only. Okay, because so far I'm talking about hill slopes, but in our country, the geotechnical problems are also subjected to the plain area, the pan India. Thank you. And now, if you allow me, I would share some interesting results of Northwest Himalaya, and this is something new. So, should
Yes, sir,
I?
please. Yes, sir, please.
Okay. So I don't know whether this slide is it visible?
Yes, sir.
Okay. So what is happening here? Before I come to the slide, let me go to this slide. Okay, now you can see this Google Earth image.
Sir, it's appearing. Yes, sir. Himalaya
Okay.
valleys by the name.
Yes, yes, yes. So in this picture, the first valley in the north, this is Satluj River Valley. The second is Yamuna River Valley. The third is Bhagirathi River Valley. The fourth is Alaknanda River Valley. And the fifth is Kali River Valley. So all these major five river valleys control, I would say, the geomorphic response of the terrain. They actually transform the landform. So what we did, all these five major river valleys have landslides. So we tried to understand that all the landslides in these valleys, do they have any common thing? I mean, are these landslides are affected by the external parameters? So what we did, we we tried a scaling relationship. We tried to find a scaling relationship, landslide area and volume scaling relationship. I'm sorry. This scaling relationship is very common in glaciology and statistical analysis, in which the volume is equal to alpha a to the power theta, and the theta is scaling exponent. So as you can see, the horizontal axis, the Kali River Valley, Alaknanda River Valley, the Bhagirathi, Yamuna, and Satluj. This figure is not subjected to only landslide researchers or geologists. I would say that even the geotechnical engineers, it is a point of interest, because all those companies making tunnels in Himalaya for the Char Dham development project or any other project, they need to have an understanding of the landform, that how things are different in different river valleys. In Kali River valleys, as you can see, the black line represents the debris slides. The black line, it is increasing towards Satluj Valley, and the red line, it is decreasing towards Satluj Valley. The black line implies that the landslide volume from Kali to Satluj becoming scale invariant. Scale invariant means they would have same shape irrespective of scale, and that is only possible when the landslide frequency is less, because then only the hill slope can retain the volume. So when a geotechnical engineer, he would suggest any excavation, he would suggest any foundation in such terrain. So he or she needs to have a basic understanding of the terrain, not only of the rock, also about the soil and the soil formation, the soil thickness, the variability of soil. So in the Satluj Valley, the frequency of slope failure is relatively less in comparison to the valley Kali and Alaknanda. And now there are two hypotheses which might be responsible for this. The first one is the rainfall variability, and the second is earthquake variability. The rainfall variability is, as we are going from Kali towards Satluj, the rainfall is decreasing in that region, and the cause is Indian summer monsoon. I will come back again to this figure. The Indian summer monsoon, it is coming from this side, from Kali and Bhagirathi, then towards Satluj, and it is depleting. It is depleting in moisture. So once it reaches Satluj Valley, it gets dry, and as a result, the slope failure activities and the slope frequency become relatively less in these valleys. Similarly, the earthquake activity, as you can see, the shear stress rate is relatively higher in this region, and it is decreasing in this direction. And again, I mean, the cumulative seismic movement, it is higher in this region and it is decreasing in this region. This is due to the fact that in the Kali or Alaknanda, I would say in the Nainital and Nainital region or the Kumaon region, the earthquake and the seismic activity is relatively more in comparison to the Satluj River Valley, or I would say Uttarkashi or Dehradun region. So this discrepancy in the seismic activity and the rainfall variation, it affects the slope failure frequency. And again, the topography, it plays a huge role because the topography is increasing towards Satluj. So the moist winds carrying moisture cannot go beyond a threshold and hence they precipitate. So in this figure, we are trying to convey a message, or not only message, a kind of comprehension that the slope failure frequency is relatively more in the Kali or Alaknanda region, or I would say in the Nainital and Almora region, and it is depleting towards Satluj, towards northwest India. And the possible factors are the variability of rainfall and earthquake. So all those construction or the consultancy agencies involved, like the geotechnical engineers, structural engineers, geologists, they would have this understanding in their mind while planning or proposing any structure.
Sir, what is this gray part into the figure? What is it
Okay,
highlighting?
is it visible?
Yes, sir, it was visible. Now it's not.
Okay, okay. So this gray part, okay, just a minute. Now is it visible? I hope.
Yes, sir. Now it's visible.
Okay, this gray part represents a transition as you are coming from Kali River Valley, from Alaknanda, then Bhagirathi. This transition also comprises the Dehradun region in Uttarakhand. There's a transition of all such activities. The rainfall, it is decreasing in this direction, but the Bhagirathi, it represents a transition, this region, also in seismic activity. And this transition recently has also been observed in the main Himalayan thrust, which is of subsurface, a subsurface ramp-like structure. My colleague, Dr. Shreya Arora, she's an assistant professor in USA at present. She observed that in this region, the Bhagirathi region, the Dehradun region, the MHT, main Himalayan thrust, has a ramp-like structure and which is fragmented in this region. So it affects the topography, it affects the seismic activity, and since the topography is being affected, rainfall is also affected. So it affects literally the hill slope failure frequency also. So things are interconnected. The hill slope process is a superficial process which is being subjected to the rainfall, and the rainfall is subjected to the topography, and the topography is subjected to the earthquake or the seismic activity. So everything is happening in a positive feedback manner.
So, sir, what you said that the humidity, the humid rains, sorry, the humid winds cannot be traveling for this particular region, and that's why they get precipitated early only. So, sir, how can that be connected to that earthquake sort of aspect?
Okay. So your question is that how the moist winds are subjected to earthquake.
Yes, sir, how can we relate to that earthquake phenomenon?
Okay, so actually the winds, when the winds travel, I would explain through this figure. When the moist winds travel from this side, so they carry moisture along with them. But then in the Bhagirathi Valley, this valley, the topography is increasing. So the moist winds cannot carry enough moisture to ascend the mountain and they precipitate. And by the time they cross the mountain, they become relatively drier, and hence the moisture is less, and hence the slope failure frequency is less. Now the question is how moist winds are connected to the earthquake. Earthquake, due to the what is earthquake? I would say the release of seismic energy, the sudden release of seismic energy. Due to these tectonic movements, the topography is being affected, and this change in the topography, I mean, and how it changes, let me go a little bit deeper. When there would be more rainfall in this region, more rainfall will result in more denudation. More denudation, it will affect the isostasy hypothesis, and that will result in increase in the topography. A little bit physics involved here. More denudation means more erosion, and more erosion means in order to maintain the balance, the topography in this region will increase. And at the same time, you have higher seismic activity here. And this higher seismic activity, it supports this exhumation of topography. So here, climate and seismic activity are working together. Now, this is difficult to comprehend that which factor is working primarily because everything is happening in a simultaneous way. I hope that makes
Yes, sir.
sense.
Yes, sir. Thank you, sir. Sir, we have a question in the chat box. What is the best software to analyze the slope stability?
I'm sorry for my cough.
No, in
Okay.
fact, we are sorry, sir, that we are troubling you even if you're
No,
not
no, no.
well.
For slope stability, if you are considering a continuum slope modeling, I would say a rock slope without any joints, then finite element method. You can perform using Plexus, you can perform using RS2 in case of 2D. If you are interested in 3D, then RS3 you can use. If you have a hill slope having so many joints and discontinuities, then I would suggest this distinct element method, UDEC software you can use for 2D and 3DEC you can use for 3D. But I know that these softwares are really expensive, and as a student or as a practicing geotechnical engineer, it might not be feasible to perform. So I would suggest that because I have been in industry, you can contact some research institutes. They have access like IIT Bombay and CB Rai Roorkee, Vadia Institute of Himalayan Geology. They have all such licenses. You can contact them and you can work in collaboration. As a
Sir,
geotechnical engineer,
is there a possibility of collaboration with the Vadia Institute?
yes, in Vadia Institute of Himalayan Geology, Dr. Vikram Gupta, he is working on landslides and on geotechnical engineering. So, like I did my PhD with him. He's a nice guy and easygoing. You can approach, and I'm sure he would help in his capacity. It is possible.
Like, sir, is there any freeware that is available that for some preliminary sort of or basic sort of the
Yes, yes,
concept
yes.
that can be cleared by students?
Professor Griffith in Colorado School of Mines, he has developed an open source software for finite element method analysis. So that is accessible from his web page. So maybe I will share, and maybe I'll share you or the organizers, and they can share the participants. It is free of cost. And Dr. Griffith, he is a well-known name in finite element modeling. So, and you can contact him, and he's easily approachable guy. So yes, there are freewares. Of course, I mean, you would not have that much luxury to perform a fancy maps, but yes, it is possible.
Thank you so much, sir. We would like that information to be shared with us, and so
Thank
that
you.
we can even share it with the participants.
Thank you. Thank you so much. Thank you. Any other question?
The participants, if you have any questions, we encourage you to type in the chat box, or please unmute yourself. Please come forward and interact with sir.
Please, can you share your email ID? So yes, I will make it public, my email ID. So any one of you having any doubt in geotechnical thing or anything, you
Sir,
can
they
call.
want your email ID to be shared.
Yes, I'm writing here so they can contact me if they have any doubt.
That was very kind of you, sir, that you accepted a request. I think probably you have landed yesterday only in India. And
Yes, I came a day before yesterday, and since there's a change in my region, it was snowfall there in Belgium, and it's hot here, so I had some problem.
yes, because of the climate change, probably you are facing
Yes,
some throat problem.
yes, apparently.
And there would be a like time lag also, sir.
Yes,
Jet
a
lag.
4.5 hour difference, so there's a jet lag. So I'm sleepy at present.
Yes, so it seems so that whenever there is this time difference, we always have to face this challenge of jet
Yes.
lag.
So I mean,
So
Uh,
how are the
and
how was the scenario over there at Belgium and as compared to Indian scenario?
scenario in context of research, you mean?
Yes, sir. Research.
Yes, the main difference is about administration. There you have a lot of access to the resources, the funds. And when it comes to our country, of course, we have such a huge infrastructure. India is a huge country. It is equivalent to 70% of Europe. But at the same time, we have too many candidates for PhD or for postdoc. So the fellowships, we have a lot of discrepancies there. In Belgium or in Switzerland, you might get 2,800 euro per month per postdoc, and here I would say the less. Accessibility to research, accessibility to the facilities, we have a difference. So I would suggest, yes, we have a lot of facilities there, but at the same time, in our country, we have too much competition, I would say.
Yes, sir. Performing research over here is a challenge in itself. We have
It is,
to
it is.
we have to
Actually, in our
struggle for
country,
resources.
the yes resources plus some, I would say, some administrative hurdles which can be removed.
So it's because of people like you that we keep on motivated that we should definitely keep continuing research.
Uh,
Otherwise, the
I- I'm
scenario is very
I'm
challenging over here.
I'm just a beginner. I'm nothing some big shot. I'm just a beginner. I mean, I try to improve things.
So it is a wonderful interaction with Vipin sir. And I
Thank
request the
you.
participants if they are working in this field of research or if they want any support, he will be definitely glad to help you out. He's already typed his email into the chat box. You can contact him and definitely he will be helping out with the collaborations, which
And if
are
you still have any doubt, I mean, I'm not available because I'm going to start my field work in Northwest Himalaya. Sometimes it's not accessible internet all, so I'm sharing my contact number.
so even the topography over there might be challenging in Himalayas, right?
It is. I mean, we have to do some field work even in the glacier terrain, so it will be challenging.
So how do you manage to work in such a challenging environment?
We just want to do, and rest is, I mean, easy.
Yeah, that's it. Where there is a will, there's always a way.
Yes, yes, true. So
So
thank you so much for
Vaishali ma'am has
allowing me
also
to share my
complimented.
experience, and thank you so much. I'm always available to
Thank,
discuss.
thank you so much, sir. We have
Thank you.
compliments in the chat box. That
Thank you.
that was a wonderful session, and I personally thank you, sir, for managing out time from your schedule. And in spite of this jet lag, you agreed to be with us with this
My
test
pleasure.
session. It was a
My
pleasure
pleasure.
interacting with you, sir, and we hope to get in contact at future again for some training programs or maybe some collaborations.
Thank you. Thank you so much.
Thank you
It's
so
it's
much,
truly.
sir.
Thank you.
It was a pleasure and privilege to interact with you, sir.
Thank you. Me too. Okay. Okay. Have a good day.
Have a nice day, sir.
Thank you. Bye.
Bye,
May I
sir.
hang up now?
Yes, sir. Thank you so much.
Thank you.
Participants, we would like to have your feedback of the program that we have conducted so far. So we would request you to please unmute and give your valuable suggestions to us. आपकी opinions, suggestions are most welcome to us. Please tell us where we are lacking or where we should do some improvements. Participants, please, we have time to interact with each other. And after two, we will be having the assessment session followed by the valedictory. So we request you to please interact with us, give us your valuable feedbacks, opinions, and suggestions. I would also request the participants to switch on their cameras as well so we can have a screenshot. Participants, you are requested to switch on your cameras if possible.
That was a great session by the IIT professors and all the other faculty members. So it was nice to meet all of them and have a great knowledge towards the or beyond the structural engineering part from the geotechnical point of view. So it was, I really like thanks to all the IPS Academy faculty members and especially to the Amit sir and Vijay sir and Devanshi ma'am for conducting this type of sessions and for interacting the students with the IT professors also. And we have learned so many things so far that the improvements and the earthquake analysis and designs of the structures as yesterday that they had told us about the Bhuj earthquakes and how the solutions will be implemented over there. So it was nice interacting with them all. And today in the morning session, the sir told us about the slopes and the stability of slopes and the various things to implement the solutions when the slopes are not stable and they will just like that the landslide will occur and the in river also the silting will takes place. So we have just enjoyed the session and learned many new things which will be beneficial for our future from an industrial point of view as well as from the theoretical point of view, ma'am. Thank you so much, ma'am.
Thank you so much, Hussein sir. That was a valuable feedback given to you, and thank you for being attentive during the sessions. I request
Thank you, ma'am.
if any, thank you so much. I request if any of the participants, if they would like to share their opinion or suggestions with us, please unmute yourself and come forward, or you can even type in the chat box. We always have been putting efforts to make a bridge between the research organizations who are working well in the country and the academic institutions, because that is the only way in which we can think of developing in the future. So it was always been an earnest attempt by IPS Academy to keep organizing such programs to have a link between the different types of organizations. So I hope this is a good platform offered to you to get in touch with people who are working in the field, who are relatively having much more experience with research facilities. So hopefully that it will be fruitful to all of you. If in later case also, if you find something that with which we could help you out with our laboratory facilities, you all are welcome over here. And in fact, if you have any other problem in reaching out to the experts, please let us know. We will be definitely glad to help you out and assist you. So we'll be taking another 5 minutes for your valuable inputs. Any of the participants, if they would like to give their opinions, please you can come forward. See, this COVID has definitely brought us towards a platform in which we can have interactions with people who are unable to interact with us in person. Because whenever it's like such sort of development programs, usually it used to be in-house earlier, in which we had to call certain experts and then conduct different types of sessions. And that was subjected to the availability of the expert, whether he is able to travel a distance or not. But COVID has definitely brought this positive aspect into our lives, in which we can interact over this online platform, get suggestions, and their valuable work be shared with us. I think this is one positive outcome of this COVID that has happened, although it is very much challenging on other fronts as well. Carrying out academics and other activities is really becoming challenging. But this thing has definitely added up uh, to our knowledge, in which we can attend such online programs at the comfort at our homes, and we can definitely, those who are interested, they have a chance to get exposed to different fields in which they can benefit. So, participants, what is your opinion about online such courses being conducted? Are they fruitful? Is it useful for you? Or are you having some difficulty in understanding some content? So, can you please share your opinion about what is the difference between this in-house faculty development programs and this online development programs? In which way it can benefit you, and what are the problems or challenges which you face in these types of online programs? Now, I believe there's certainly is some problem with online programs also, although they can be attended um, in this virtual mode, but I think not 100% of it is graspable. That's what I personally feel. If you have any opinions, please share with us. Vaishali ma'am has shared that it was a wonderful effort. Thank you so much, ma'am. Thank you, Vaishali ma'am. You have been very attentive, and you have been responding to a lot of sessions, I believe. She says that we got the chance to interact with all the teachers who are best in their fields. I really enjoyed a lot, and it was very useful to me. Thank you so much, Vishali ma'am. Although there are a lot of people still now getting into this new field of geotechnical earthquake engineering, so we have tried to get some experts to interact. Probably there might be much more number of experts in future who might be working in this field. And Shashwat Chatterjee has responded that online faculty development programs are easier to attend. Yes, ma'am, definitely. I don't know, ma'am or sir, pardon me. So definitely it is easier to attend, but I personally feel that it is not 100% graspable, because PowerPoint is such a platform in which after some time you tend to be sleepy. It happens naturally. It is not because of any content or so, but usually PowerPoint are like they are lullaby to a small baby. We tend to be sleepy after some time. So that is one constraint which I feel that we can be attentive only for a shorter duration of time in these sort of online programs. And the content has to be very lively, otherwise you tend to be sleepy. So is it that is the similar feeling with you all? And one more thing I feel that unless and until the participants are switching the camera on, we don't feel this platform to be lively. It feels as if we are just talking to ourselves. Is that the similar feeling with you all also? Thank you, Shashwat. Shashwat, sir or ma'am, I don't know. Uh, they say that he or she would be grateful if an FDP on statistical and probabilistic geotechnical engineering can be organized. Definitely, sir. We would take your opinion and suggestion. And definitely, this is relatively a new field of research to be explored. And we shall think about organizing the next faculty development program on the similar aspect. Thank you so much for your suggestion. Any other suggestion which the participants would like to have, or any other field to be explored, so that we can even think of the new aspects that are to be still touched upon? Because discussion is the only way with which we have new ideas. So although it is not possible for you all of you to switch on your cameras all the time, but still I would request that switching on your camera actually motivates us that yes, you are being looked upon. So that is what I would request the participants to, because that makes the environment lively. I don't expect it to be switched on all the time, but at least for say 2 to 3 seconds, it makes the thing become lively. Thank you so much, Shashwat sir and Anuj sir. Thank you for switching on your cameras, and thank you
Thank
for
you
your
very much, madam.
thank you, Vaishali ma'am. Thank you for your lovely feedbacks and suggestions. We would definitely try to incorporate in future. And see, this is what the difference is. When you switch on your camera, it actually we can get connected. Although on virtual platform, it feels that we are having a connection with you. So Satyaprakash sir has also responded that thank you IPS Academy organizers for this FDP. Some of the sessions were really very helpful to my research work. Definitely, sir, 100%. We don't expect that you would be able to grab 100% of the knowledge that is being shared. Even if 60 to 70% is conveyed, then our purpose is useful. So that is what we expect, that not all the subject areas are graspable by all the participants because everybody has varying degree of research. So it was lovely to have such participants. In fact, it is because of the participants that these types of faculty development programs are being organized. And without participants, I don't think these programs are fruitful even. So it is because of such lovely participants. I thank all the participants for being, especially interactive participants, that definitely motivate us to keep conducting such types of programs. Thanks once again to Shashwat sir, Vishali ma'am, and Satyaprakash sir, um, and all the participants who have been paying attention. Thank you so much. This is on behalf of IPS Academy, Institute of Engineering Science, Civil Engineering Department. I am taking your leave for now, and at 2 p.m. we will be joining again for the yes, Harsh. I think right now we had an interaction with a participant also. And if anybody is still willing to give their feedbacks, informations, or anything which they want to share, you're most welcome. So as of now, I'm leaving, and we will be meeting again at 2 p.m. for the last session. That will be the assessment followed by the valedictory. So I hope to see you at this important session, because you all know that if you don't attempt the assessment, that will be difficult for us to give you certificates. That is the instructions given by ATAL FDPs. So we have to take this attempt of the assessment, and I request you all to please be there at 2 p.m. So we'll be joining for the last session, and we'll be concluding the faculty development program at that time only. Thank you so much. You may have a lunch break, and then we will be meeting at 2 p.m. again. Definitely, ma'am, Vaishali ma'am, it is very challenging because we have to be present all the time. We have to be attentive. We have to organize this program as well as conduct it. So, like from organizing till conducting, it almost takes a full one month. So we have to get in touch with the speakers. We have to then ask their suitability time. We have to organize the schedule. We have to then plan it, conduct it, and then after that we have to wind up with a report. So in all, it is a full 1 month's efforts that are to be put in for this 1 week program. So as such, it's 1 week, but completely it takes 1 month. So thank you so much, Vaishani ma'am, for appreciating and understanding that yes, it is a very tiring job. In fact, I'm grateful that you could observe such so much of my efforts. Even you are nice. You are great. I'm grateful to all participants like you as well, ma'am, for attending and making our efforts fruitful. So I shall take your leave for now, and we will be seeing you at 2 p.m. again for the last session of assessment and valedictory.